Quick check. All right, that sounds loud enough. Good evening. Thank you for joining for the last session for the day. It's usually not the best session to give, but there's a very special reason why we tried to schedule this session at 5 o'clock Spain time, because just about now, or another 5 to 10 minutes, in US, we're doing a corresponding session at the Build conference, and there are a whole bunch of services that are going to get announced, which we could not talk about all this while, so we had to make sure that we stay embargoed all the way till 5 o'clock right now. So what you're going to see hasn't been seen before. Well, some of it, of course, is. We're going to talk about 2 new services that we're going to be announcing a preview of today. And that's the reason why we had to wait till 5 o'clock on Thursday evening to do this session. So thank you again for joining. I'm Karandeep Anand. I work on the Windows Azure engineering team. And my team is responsible for the Azure portal, monitoring, management, and essentially DevOps solutions in Azure all up. Also billing. So if you have any gripe about billing and questions, feel free to catch me at Ask the Experts. But today I'm not going to talk about billing. I'm going to talk about mostly around monitoring and management. I'm assuming most of you are familiar with Windows Azure. Just a quick show of hands. All of you use, anyone who does not use Azure today who hasn't tried it? Oh, great. So then we can actually skip through a lot of the foundational stuff and just go deep into some demos. Just a very quick recap, just a level set on terminology that we're going to use. Windows Azure essentially is built on the same Microsoft cloud infrastructure where we run all our big properties like Skype, Bing. So it's a pretty hardened platform that we use under the covers. On top of that, Azure offers a pretty robust compute tier, what is a combination of both IaaS and PaaS, which is everything from getting a virtual machine or a more abstracted PaaS form of application hosting like websites, mobile services, and something in between, which is very unique to Azure, called cloud services, which gives you a machine, but you don't have to necessarily manage it. So you have the flexibility of both. And in the context of management, these concepts are very, very important because what you manage and how you manage significantly varies depending on which stack you choose. We'll talk about that in a minute. On top of these base compute services, we've built our own set of services ranging from everything from identity to integration to data. And this list keeps growing every time I do the slide. We've had last time I was here, I was at TechEd in Europe. Since then, we've done 100+ releases in Azure. So in a period of about 10 months, there'll be 100 releases that we keep doing. So every time this list keeps growing. And the meta point is that apart from the core compute and core infrastructure services, we keep building these high-value services which you can just plug and play and use, so you don't have to go rebuild things that are not core to your IP or core to your business, and you can just get them off the shelf. And a whole bunch of those services are available, and these are fairly high level, so you don't have as many management concepts to deal with. And we'll talk about how that impacts your management strategy all up. And of course, on top of that, Azure offers pretty much every language support. Of course, in the infrastructure level, we offer both Linux and Windows, but also in the programming model and tools, there's support for everything from .NET to Visual Studio for our most Microsoft loyal audience. At the same time, we do support fully the Java stack. And if you noticed or caught up on the announcement that we recently made between Oracle and Microsoft, we actually support Java as a first-class citizen, both in Windows Server and in Azure. So a whole bunch of great pieces of news this week, and you'll hear more in the next 1 hour or so. So what I'm going to focus on is not any of those services. There are a whole bunch of sessions about that, but a complete horizontal solution which cuts across all services, which is the management, monitoring, and DevOps solutions, including auto-scaling. And that's a service we launched a preview of at 4 a.m. this morning, and we'll talk more about it and see some demos real time today. So I'm going to focus on this green bar, and I'll try to use mostly demos to just get to concepts, and feel free to stop me along the way. It's a small enough audience that I can customize it to talk about what you want to hear as opposed to what I want to talk about. So I initially mentioned what you have to think about from a management strategy all up for Azure depends heavily on what stack you choose to use from Azure. So let's contrast this with if you're doing your own data center or have your own server farms that you manage on premises. You're responsible from everything from network hardware to server hardware to the actual operating system and the virtualization stack upwards, all the way to the actual application that you're building. And that's the traditional on-premises IT, and that's what you have to worry about and have contracts and management around. But when you move into a hosted platform like Windows Azure, depending on whether you use virtual machines, a higher level layer like cloud services, or an even higher level abstracted layer like websites or mobile services, the level of management that you need to worry about significantly changes. And this is usually a good framing thing to worry about when you are on a whiteboard and looking at total cost of ownership, or you're thinking on what tools to go use and deploy and manage. It really matters which stack you choose to use. So for example, if you want to use virtual machines, and these are existing applications that you run on premises, all your existing tools should just work as is, but you still have to think about how cloud is different, where you have no access to the server, we have no physical access to the hardware or networking switch, and how your monitoring strategy will change. And we'll talk about that in a minute as well. But when you start using higher abstracted services like cloud services or mobile or web, the number of things you have to worry about starts reducing significantly, and you can focus more and more on your application as opposed to focusing on the actual underlying infrastructure itself. So it's really there's no right answer. There are perfectly good use cases for starting from virtual machines, or if you're building net new applications to use things like mobile and web services. The level of abstraction, you do give up some control because you don't have to worry about patching the operating system, but that also means that every time we patch the operating system, if your application does break, you need to worry about that. So think of that trade-off when you are thinking about putting together the management strategy for all your assets that you run or will run in Windows Azure. So with that context and frame, going deeper into how do we think about management services in Azure, we have all these core compute services, but all these building block services varying from CDN, traffic manager, databases, storage, and this list keeps growing. But one thing we've done across the platform, it's a pretty strong promise we make for all services, that we'll offer a consistent set of management REST APIs for all services. They all look the same. They all feel, as it's been built by one team, one company, and we've standardized on certain constructs in the management REST APIs, and also made sure that you can access these regardless of which platform you work from. So whether you choose Windows or Mac or Linux or all of them, there is a clear access mechanism, both through API and PowerShell and command line tools, if you don't wish to use the UI or the portal. So there's a full access through the actual browser, which is cross-device, cross-platform, so you can actually access it from any device, including mobile phones. It's not optimized for mobile phones, but for tablet it works really well. You can definitely script, and I want to show you some simple demos on how to use PowerShell or cross-plat tools as well, just to orient yourself to the various options available. And of course, there are a whole bunch of third-party tools as well available, including third-party, what we call third-party internally, like System Center. So just a quick show of hands. How many of you use System Center today on premises? System Center, 2 customers. Okay. I have a few slides in System Center, but if there's not a lot of interest, I can skip over that and go deeper into automation and DevOps instead if needed. So enough slides and talking. Let's just do a very, very quick walkthrough of the Windows Azure portal. And what I'll do is, hopefully, if you use Azure, pretty much have to use the portal. But what I want to do is just give you a consistent overview of what the services are, and more importantly, any best practices and tips and things to go do to manage your infrastructure better. So one of the first things is, before we get in here, this is the login screen for Windows Azure, and I'll try to log in using my Live ID or the Hotmail account. And this is a typical thing that, oops, no. What I have set up here, and that's the first best practice and tip that I would highly recommend everyone to set up and use, is do set up a 2-factor authentication into logging into your account. So what I've done here is made sure that even if somebody has access to my Live ID and account, they cannot log in because I've set up a 2-factor using an SMS check. You can do it with email check. But this is the number one access control mechanism loophole that people exploit. So that's one thing to worry about. A better alternative to this is using Windows Azure Active Directory. So if you have Active Directory with Windows Azure AD, you can actually use organization accounts, including domain accounts, to go access Azure. So when you're thinking of identity and access, that's the first thing to worry about is how you set up access control to all the services and assets in Azure. And so I just want to show you a very quick example of setting up two-factor auth. The good thing is you can also do this with Microsoft accounts or live accounts or Hotmail accounts, whichever you want to call them. In this case, I've set it up to do it using text messaging. So I'll wait for my text message to arrive. If it doesn't, because I'm on international roaming, I'll switch back to the portal and jump in right here real quick. So that's the first thing to think about is from just pure access and control mechanism. Of course, when you are using Azure and trying to do automation, you will not be always logging in and logging out. So there's a notion of management certificates, which we'll talk about. That's the second mechanism of accessing Azure, which is there are these 509, X509 certificates that you can use after you've authenticated once. That is what we would typically use for PowerShell or for any automation and batch scripting. So you have browser-based interactive login. At the same time, you have management certs that you can deploy and upload your own certificates and use that for any automated tasks. So think of that from an access control perspective as the first thing to worry about. What you're looking here is the now very familiar Windows Azure portal. And from a management perspective, let's just take one particular simple website. And I'll walk you through some core sections just to orient yourself. And there have been a lot of features, including one that just showed up here right now, that has been added in the last 3 to 6 months. So let's just do a 10,000-foot view of everything you're seeing here. So at the top level, what you're seeing is just a dashboard view of how my entire website, which is a website plus database, behaving all up. So out of the box, Azure provides simple monitoring and metrics. So you don't have to write any code or deploy any agents to get these metrics and this level of detail. The second tab is a more detailed monitoring view to get the health of your application. And these metrics today are not available through API, but it will be soon available through an API as well. So you can get into pretty detailed metrics and start seeing history for how your site's been performing, and similarly for VMs and for cloud services over a period of 6 hours, 24 hours, and up to 7 days. The next big section, and you'll see this consistently across all services we offer, is the configuration and config management, or config lifecycle management parts to it. So for example, this is a combination of showing a bunch of things that are typically in web config because of the websites, but also things like certificate management or managing domain names or doing SSL bindings. For each domain, when you look at this for SQL or you look at this for Hadoop, you'll see different sections, but typically anything to do with access control, security, binding, domain names, certificates is what you'll find in the configuration section, and that's what allows you to customize it heavily. The other and the most important part here is that all the monitoring settings are also found in the configuration section, which is both the traditional monitoring, whether you want to enable logging or not, do you want to get detailed error messages, verbos, different levels. You can change all of that at runtime, post-deployment, so you don't have to necessarily make the right choices up front. You can always do it later. In addition, you can also, Azure offers 7 days historical metrics out of the box, but you also get a fuller, longer retention in case you provide your own storage account to keep those metrics. Other than that, there are a whole bunch of these other things which are specific to a domain, but that's what the configuration section you'll see on every service we offer. We'll have a dashboard, have a monitoring, we'll have configuration. The fourth tab, where all the new features today will light up, is around the scaling. So scaling is a first-class concept in Azure where the promise of cloud is it's elastic, capacity on demand, and with a simple slider, you can increase and decrease capacity as needed, and you will be charged only for the period of which you've used the capacity. And there are a whole bunch of new sections on the screen now, and they're around auto-scaling. And we'll talk about the feature releases that happened this morning. Now Azure natively offers auto-scaling out of the as thing. So don't worry, we'll spend a good 10 minutes deep dive into auto-scaling and how it works. But if you can not tweet that for the next 30 minutes, I will be They'll be very happy with that because I'm out on a limb. My president, personal is awesome. And after 30 minutes, you can tweet whatever you want, not an issue. We just happen to start 30 minutes earlier here than in US, so just want to make sure that I don't get fired before I get back. Yeah, my president is going to show this, so I'm pretty sure he won't be very happy with this if I steal his thunder. Anyway, but you guys made it for a 5 o'clock session, so I have to give you some stuff before everyone else gets it. So, and you'll see this typical behavior across all the services, whether you're managing virtual machines or you're managing websites, a whole bunch of getting started tools and tips to detailed dashboards and monitoring. They're all offered out of the box. And every few weeks we keep releasing new features. And typically, monitoring and management is one very, very heavy area for investment for us because apart from getting started, the other biggest blocker for adoption of cloud right now is the availability of free, simple to use tools at not a lot of extra added cost. Did I mention that the service is still preview? So you'll start seeing a bunch of these popped up errors. Hopefully they'll go away soon. Now, one other thing I want to show you real quick is the Azure command line, and actually I'll tell you how I got to this point. So on windowsazure.com, if you go to the download section, apart from downloading the SDKs that your developers would use or you would use, there are a whole bunch of tools available as well, whether you are on a Mac, Linux, or a Windows box. So what I've done here is I've installed both the Windows PowerShell tools, so you can access and automate and deploy using PowerShell. At the same time, I also have these cross-platform tools, which I can use from my Mac or use from my Linux machines or Linux desktops to manage Azure. So before you can use this, one of the first steps you have to do is download the management certificate that you need to access your subscriptions and accounts. So this will be typical Azure. You'll get a list of all the commands on all the services, and this list keeps increasing. So more and more, we start offering every service that you see in Portal. We're almost standardizing that you will have an equivalent PowerShell and a command line experience for all the services. So this list keeps increasing. So every time you see a new service pop up, you'll see the command line support for that also. You had a question?
Something about the authentication certificates. Is there any way to separate certificate you download via published settings by subscription? Because I have multiple subscriptions and it's something like I don't want to have in the same settings.
Right. So the question here was, is there a way to... So today, and I'll just walk you through what the problem typically here is. We made it a little too simple where when you download the management certificate through the command line tools or through Visual Studio, Azure automatically generates the same certificate across all your subscriptions and uploads it for you. You don't have to use that mechanism. That mechanism is only for the simplest out-of-box scenarios. You can always upload your own management certificate and use that, and never download the ones that we automatically generate for you. In fact, it's a good practice in steady state to always generate your own management certificates and maintain them. The biggest benefit of that is you control when the certs expire, the cert rotation policy. So as an advanced user, you can come into the settings page and manage certificates across all your subscriptions that you have access to right through the portal and disable them. So if you've generated a whole bunch of these management certificates using any of these tools, you can always go delete them per subscription. That's the other mechanism to just go clean it up. But that's a good point. Management certificates are the keys to the entire kingdom. Anyone with access to the management certificate can do whatever they want with their subscription. So if you don't want a very high bill, we do have some other quotas in place, but if you don't want very high bills, make sure the management certificate is a very, very sensitive thing to maintain and secure. So do watch for that and not distribute it broadly. Back to this real quick. So what I'm doing here is I saw the list of websites through the portal, and I'm going to do the same thing but through command line just to show that I'm connecting from a command line terminal. This could very well be on a Mac, and tunnels through, talks to Azure, the management and REST APIs, and gets the list of sites for the current subscription. One big difference between the portal and the command line tools, the PowerShell tools, is the portal works across all your subscriptions at the same time. So if you want a full view of all your resources across all your services in Azure, The portal gives you one consolidated view. You can filter that out. In case of a PowerShell or command line tools, you're working on one subscription at any given time. So if you want a similar behavior in Azure, you can use the subscriptions filter. That's another feature that was recently added, where if you work with multiple subscriptions at a time, either with multiple customers or within the same big enterprise, you have multiple different departments, different subscriptions, you can set access control as well as views depending on which subscriptions you want to see or not see. So in this case, for example, I don't want to see these two subscriptions data. I can easily filter it out. It'll also make your access to the portal a lot faster if it doesn't have to download all the services. So one other real quick thing as an overview before we get back into the slides is the ability to set co-administrators, so as soon as this loads. And that's the last identity and security concept that I'll talk about today, is this whole notion of being able to add other people to your subscription as co-admins. And what this does is it does not give them access to any of your billing data or subscription metadata, so they cannot change or see your credit card or your invoicing information, but it does give them full access to deploy services, create services, start, stop, or do whatever they want. But they can generate more bill for you, but they cannot change any of the billing stuff. So co-administrators is also something that you manage natively through this portal. In this case, a bunch of folks on my team, we use the same set of subscriptions and services, and we share them using co-admins. So with that background, I'll just quickly go back to slides and talk about what is really happening under the covers. So this is a 1,000-foot view of how Azure's internal management services run. So whether we're accessing through the management portal or through a CLI or the PowerShell scripts or PowerShell, or including third-party tools. All the third-party tools available in Windows Azure Store, as well as things like System Center, use the same set of management APIs that we use internally. So there's no feature difference, or there's no special access that we have that you don't have. So if and hence there is nothing you have to worry about being locked in, because all the data models are completely accessible to you the way they are to us. So the same UI code that we write to access to the portal is what you can go do through your own automation. So if you have custom dashboards or special scripts or special tools you use today, you can make them point to the same API and use management certificates to automate. Under that API layer, which is a proxy essentially, is access to the application manager, which in turn gives you access to all the services that you use and provision in Azure. So if you use SQL or websites or mobile or Hadoop or databases, you have access to all of the services via the application manager REST interface. Similarly, we plan to add support for both billing and monitoring through the API. Today, billing and monitoring are not available through the API. And that's, even though there's support for getting basic information, detailed information about metrics or my billing data is on the roadmap for you to access. Marketplace is the Windows Azure Store. I'll talk about that a little later in the talk. But you can do everything from simple deployment provisioning of your services to advanced upgrades, management, rolling upgrades, all of that through the API. So with that, I'm going to shift, because today's talk, I'm going to really focus on all the new services we just announced, and shift gears towards both monitoring, both as from a developer perspective as well as from an IT pro perspective, on how you do DevOps in Azure and what tools are available out of the box and what you can go build on top of. Before we start seeing more demos and alerts and auto-scaling, sorry, go ahead. Your question. So the question was, I'm going to repeat questions for the recording, but the question was, we keep adding a lot of new services in Azure every few weeks, months. For example, we just announced BizTalk was probably the newest service we announced. There was Hadoop before that. And the question was, when these new services come online, do we offer the same management REST APIs and command line tools for them, or they usually lag behind? Interestingly, one of the big principles when we rebuild the entire Azure management stack was our team, or my team, also owns and controls every new services onboarding and shipping in Azure. So no service can ship unless we authorize them to go ship. And as part of that, we made it a pretty strong promise and criteria that they have to have APIs documented, have a corresponding SDK support, PowerShell, as well as full monitoring and metric support. Now, different services at different levels of preview will give you more richer data than less data, but they all are guaranteed to give you both REST API access as well as monitoring and metric support. And that's a common principle and theme you'll see across all Azure services, that you're never tied in and locked into our set of tools. You can always use third-party tools or your own custom tools, no matter which new Azure service you go pick. So thanks for bringing that up. So back to a little bit of philosophy conversation on how is the whole concept of monitoring and management different in the world of cloud. I mean, this applies not just to Windows Azure, but even if you are building your own private cloud infrastructure, there are certain things which are very different from how you approach and think about monitoring and DevOps in a virtualized environment like public cloud like Azure versus the typical single environment, on-premises environments you're used to. So, on premises, you have access to the actual physical hardware. You can remote desktop to all machines. You can attach a kernel debugger. All those things are available. In the world of cloud, two things change. You have no access to the hardware whatsoever. At best, you have a remote desktop access to certain machines if you're using virtual machines, but if you're using higher level services, you have no access to that. The second big difference is, by design, a cloud service and a cloud application can run on any machine at any given time. So there is no concept of a particular machine or a particular application running on a single machine that is dedicated to you. For us to give you the SLAs and high availability and disaster recovery, we keep moving workloads without impacting any of the uptime automatically. In that world, the whole notion of machine levels or machine-specific logs and counters and things don't really matter a whole lot. And that's something you have to really map in your monitoring tools today, which is if you were heavily relying on certain machine metrics or machine IP names or machine instance names, when you build net new applications or you're trying to morph the applications to run in cloud, that's something that you should abstract out so that you put enough custom metrics or enough instrumentation in the code as opposed to relying on the ability to be able to connect to the actual instance of the VM or the machine that the application is going to run on. So if you keep that in mind, so two slides in the whole deck, if you don't remember anything, because everything else you can play with, is the first slide on what levels of management you need to invest in, between different stacks. And the second is, in a cloud environment where you're talking about inherently distributed environment, the approach to monitoring, and there's a little bit of extra overhead on the developer now to how to abstract out the level of monitoring and custom metrics than it typically was. It has a great benefit because you make your application very portable, where it does come with an extra thought that you have to go put in there. So with that, I don't want to spend any more time waiting on announcing this. Hopefully it was about the right time. So there are two new services that we're announcing today. They're both preview right now. They're available. One is called the Windows Azure Alerts and Notifications, so that you don't have to, no longer have to come to the portal to keep watching it. You can set alerts and thresholds and get notified via email when things are going wrong. And I'm going to show you a very quick demo of that. And the second service we're announcing today is the availability of auto-scaling for virtual machines, websites, and cloud services out of the box for all your services based on certain set of rules. Both these services are available to everyone, unlike other previews. It's an open preview, so all existing Azure users as well as new ones automatically get access to try this out. Of course, it's preview service, so don't be surprised if you see a few errors here and there popping up, like the one somebody in the audience saw an hour ago. So yes, it's a preview service, but we would love to get your feedback on those. And with that, let's actually start playing with some of these new bits. These bits went live, 5 hours ago, so I hope they continue to work on me. So one of the typical things is, so I talked about a website I was using, and so typically you can always come in and watch how my website has been behaving over a period of time. And we give you, these metrics out of the box, which draw out, the latency, CPU, network, memory, how many errors happen, how much data flow in, flow out. And these metrics are very useful when you're doing analysis after the fact. Now, when things go wrong, you want to get notified proactively that my CPU was too high, or I had too many errors, either HTTP errors or too many requests. So one of the new things we've added is in the settings tab is the new alerts section. I already have 2 alerts configured, and I'm going to show you a quick demo of how that works. But let's just quickly walk through what setting up a new alert looks like. So for my website, let's just say anytime the latency threshold is hit. So if my customers are experiencing very slow load time on the website, so they'll come and read my blog, but the blog is loading very slow, I want to get notified so I can come and look at what's going wrong. So I'll create a new alert called the latency threshold alert. And this is essentially for my blog. Of, let's say, 1 second good enough, or let's keep a 1 second alert for now. So, and you can pick and choose assets from multiple subscriptions, all your subscriptions. For preview, there is a limit of 10 alerts per subscription. So use it judiciously. Of course, we'll remove this limit once we exit from preview. But what this does is it lists all the assets available. So in this case, it's showing me a list of all the websites available. And I'll pick my Azure e-management blog. What it does is it shows you the list of all the metrics available against which you can alert. So today for websites, you have metrics ranging from response time, and I'll talk about how you set that response time, which is you ping the site every 5 minutes, and you measure whether the site is up or down. At the same time, you also measure how long it took for the response to come back. So depending on which page you set up, and you should pick the page very judiciously as well, you can set a threshold value. In this case, let's set a 1 second threshold. So you have the regular conditional operators available, less than, greater than. Today, you cannot author your own custom rules because the number of metrics are pretty simple, but we give a whole bunch of rules out of the box. And the second concept for you to think about and worry about is how long do you want the alert service to watch your application before notifying you? So you typically don't want one spike in your CPU to send you an alert, because otherwise you'll have a lot of noise in the system. So the second concept to think about is the notion of the evaluation window or the evaluation period for which you want us to monitor the service. So for example, if you typically expect a cold load time to cause a high CPU spike, you can let us watch for 15 minutes or 30 minutes or for almost 1 hour. And depending on different services, whether it's virtual machines or websites, you'll have different evaluation frequency. In this case, let's just do 15 minutes to start with. And then you can say, hey, I want to send an email out to all the service admins on the subscription. Or you can specify an alternate email address as well. Let's skip that part. And then you can choose whether you want to enable the rule immediately or not. With this, what I've done is, anytime my customer or my website blog reader starts experiencing any latency of more than 1 second for my blog to load, I will immediately get paged and emailed. And before this, I actually have already configured an alert to do the same thing. So I'm actually seeing these alerts at emails that got generated with this. Because it's a 15-minute evaluation window, I cannot set it up and show it to you in the same demo. It takes 15 minutes to wait for it. But what I did was the system watches for your conditions over the evaluation period, and as soon as the condition gets hit, it will send you an email. However, the other thing it does is, because in general, cloud and most services are self-healing, if the condition gets corrected and you reach this normal threshold of 1 second or below 1 second, it will send you another alert or email that says your issue is resolved. So if you're sleeping overnight and didn't really wake up for it, you don't necessarily have to go look and say, oh, something happened, and do I need to still work on it or not? We automatically tell you whether we're able to automatically fix it or not, and depending on that, you get a list of alerts to go come in the morning. So If you still have any of these issues work, then you can always come to the management portal, and it takes you to the same tab of looking at the alerts. In this case, let me just quickly show this other one. It shows you that I still have one alert active. When you drill into it, it shows you the history of how many times this alert got activated as well. So even though the alert got resolved automatically in some cases, you can come back and after the fact look like, hey, every 30 minutes, I see the CPU spiking, even though it gets normalized. So you have access to the log of data on how many times the alert got kicked off. And either you can adjust your rules, or you can do things like auto-scaling, which I'll talk about in a minute, to help correct that automatically going forward. So for example, what you're seeing here is I'd initially set up a threshold of 600 milliseconds for my website. And a typical peak average is about 800 milliseconds. Sometimes it drops to 500 milliseconds. So in this case, a lot of times the alert gets kicked off, gets resolved, gets kicked off. Of course, 600 milliseconds is a pretty low threshold. So you can always come back and edit the rule and say, hey, this is very high frequency. I'm okay with a 0.9 or 900 millisecond delay, and this will, in the next evaluation window, take care of it. So essentially, what you've done here is, instead of having to come in and log in and keep checking, now you set certain conditions and rules across different metrics that you have in your application to notify you. One thing I didn't mention earlier, I should quickly show you that, is for websites, we can do the same thing for VMs and cloud services as well. You can set up something called availability monitoring. This is another feature which I shipped a few months ago, but let me talk to you about that anyway. What this feature is about is, in addition to monitoring and writing your own metrics of CPU, we also offer the ability to hit an endpoint in your application from outside of Azure. So even if there are issues, if within Azure we think everything is running fine, your customers which are sitting outside of Azure and trying to access might be seeing issues which we're not seeing within Azure. So with the availability of the endpoint monitoring service that we launched it's been about 6 weeks now, you can now set up alerts to watch and say, set up a point in let's say, Netherlands, one in Singapore, one in Hong Kong, and hit my site externally. And if any of those checks don't work, so for example, in this case, I've got Singapore, Amsterdam, and California in San Jose configured to hit my website, so you can make sure that users outside of Azure can even access it. You can configure this in the configuration tab. You can add more endpoints. You can add different. You can either you can use you have a limit of 10 today, but you can either hit the same site from different locations, or you can hit different pages within the same site. So for example, in your one application, if you have order processing and you have a shopping cart, you can independently set up different rules and different endpoints to go monitor depending on which endpoint you want to hit. So for example, I have the home endpoint configured, and I've configured this to hit from multiple locations, and I can pick either more locations, or I can say, I want to make sure that my shopping cart page is also correct, and I want to test my shopping cart from Chicago and let's say Dublin. All I have to do is hit save, and then every 5 minutes the service will start pinging it. And now with the alerts and notification service, every time it fails to ping it, it'll send you an email as well. So you can do it. You can do pretty robust monitoring of all your services, whether it's virtual machines, websites, mobile services, using the same mechanism. The question was, can you use this for on-premises websites? Today, no. Today, it's restricted to endpoints within Azure. And for one of the big reasons for it, it's a free service today. So we restrict it to saying, hey, if you're using Windows Azure websites or virtual machines, there's no extra cost for you to go use it. We do plan to offer this in a way that you can ping endpoints outside of Azure. And if you're a System Center customer today, you have this service available through System Center as well. So you can set up System Center deployments wherever you have the agent, and you can ping them. So if you're not a System Center customer, you have an external endpoint to go use, that service will also be available in the roadmap soon. So that was, so we've seen two quick things. We saw the ability to set up outside-in monitoring, so you can monitor the endpoints, as well as the ability to send alerts. Now, of course, I don't want to be woken up at 2 in the morning every time my CPU is higher than 60% or I see high latency. Yes? Yes. Yeah. So the question was, can we have a billing notification for something similar like this? So I'm assuming you want to get some billing thresholds of good request, definitely high on our roadmap. One of the features that was released 3 weeks ago at TechEd was the ability to see billing, usage, and notifications in the portal itself. So when you log onto the portal, especially when you have a free trial or an MST subscription, when you have certain quotas set for your subscription, you can see those alerts in the portal now. That feature launched a few weeks ago. We'll have the ability to be able to send those alerts through email as well soon. And then, as we evolve the billing features further, where we have custom quotas or custom thresholds, we're making sure that the whole platform enhances. But the billing notifications is in the short-term roadmap, something they're definitely working on. So just logged in, and actually it's telling me there are multiple active alerts to go work on, and you can go troubleshoot this. So one of the things that I talked about was, instead of waiting and manually coming and always taking corrective action, what we also announced this morning was the availability of auto scaling. So you can let the system or Windows Azure automatically scale up or scale down your compute capacity, so you don't have to do this. Let's take a very quick look on how you would do that. So let's start with a more complex service. So in this case, I have a service. It's an order processing backend. What it does is it takes in, there's a web front end, which takes in requests and sends it offline to a order processing job service, which keeps processing orders as they come online. So the service has 2 roles. Quick question, how many of you use cloud services today? Pass. Great. Websites? A few. Virtual machines? Wow. I thought probably there would be a lot more hands for virtual machines. That's good. See the Azure loyalists, love that. So what you see here are 2 instances running for the processing role and the web role. And it's a simple site. I wasn't expecting a lot of traffic, so I started with 1 instance each. Now, with the availability of this new service, what I've also set up is the notion of auto scaling. And let me wait for this to show up real quick. It's definitely slower today. Okay. Alrighty. So through the dashboard, you can access the ability to do, configure the auto scale. And what this will do is essentially take you to the scale tab, where you typically were just moving sliders to see how many instances you have. You can now scale based on either simple performance metrics like CPU, memory, network, or you can also scale cloud services using the queue depth. So a typical scenario will be you have a web front end which keeps taking orders, puts it in a queue, and you have a backend role which is picking up those metrics, picking up those messages, and processing the orders. So if you have a decoupled architecture like that, you can also do auto scaling based on how many messages are queuing up in that queue as well. So today what we're making available is the ability to either set up auto scaling using the CPU. So you can say, I want to watch the load on a certain role, or you can set it up using queues, in which case we can watch the queue depth. And in case a lot of orders are getting backlogged, you can increase. So if you can say 5,000 messages in the queue, increase my backend processing roles. Or if the orders drop below 100, shut down a few machines so I can save some money. So let's do a more complicated one to see all the possible features and combinations. So for these 2 roles, I'm going to set up auto scaling based on CPU load on both the roles. First concept here to think about is, how many instances do you want to spin up as a min and the max? So these are both the low watermark threshold and the high watermark threshold. You don't want to infinitely scale. That'll be a pretty high bill. I would love to have that bill, but I'm sure you would not. But that is the range you specify, because high probability that even after adding 5 instances or 10 instances, your CPU is not going down. There's something else wrong in the system as opposed to just load. So the high watermark, which is the instance count, lets you control how much you want the system to scale the service automatically. And once you start trusting the system more, you can be a little bit more graceful with how much more you add. So in this case, I trust the system and say you can go between anything from 1 instance to 5 instances on the web role. And I want to control the target CPU, which is anytime I see anything from 60 or let's say 75% to 90% spike is when you need to kick off the auto scaling. So the range, the target condition, and the last part is the most interesting thing, which is very unique to Azure. You can choose how much more capacity to keep adding as a step function. So what this is saying is, every time you see a 65% CPU load over a certain period of time, increase my number of instances by chunks of 2. So you start with 1, for example. The minute you see a spike, it will add 2 more. Then it will wait for it to evaluate again. If the load is still not corrected, it will add 2 more. So while this helps you scale pretty fast, it does add a pretty significant cost. So something for you to think about is, if you're expecting a lot of load like a Cyber Monday or a Black Friday sale, it's good to set it in big increments so you can automatically scale up like 10 instances. But if you're typically expecting an incremental update, you don't have to necessarily wait. You don't necessarily have to add all the 10 instances up front. And the last part of the rule configuration is how much time should the system wait before it reevaluates the rule and kicks in. So typically, especially for cloud services or virtual machines, it takes anywhere from 2 minutes to 5 minutes to 10 minutes to spin up the machines. So you don't want to keep checking the system every 10 minutes to see whether the load's gone down or not, because that will end up thrashing and increasing your scale count pretty significantly. So what it does is it says watch for 15 minutes after scaling to see whether the conditions improved. If not, then add more. If not, then add more, and you can keep increasing that. So that is the scale-up wait time. And the last thing here, which is the most cool thing, is about once the load has gone down. So let's assume between 9 a.m. and 11 a.m. everyone was hitting a website or an application, and load went up, and you kept scaling up. At lunchtime, when people have gone or it starts going down, you don't want to come back and manually have to go reset and decrease the counters. What the system and the last option lets you do is, it says, after I scaled up, check for the rules again at the scaled down time. Let's say watch for 30 minutes. And in 30 minutes later, start scaling down in increments of 1 or increments of 2. So the same logic and same metrics that are used to evaluate the scaling up logic also can be used to do the scaling down logic. So in both cases, you don't have to worry about, once you set up the system, you never have to worry about right-sizing your deployment. You can just make sure that you set the whatever you care about, whether queue depth or CPU, and your system will automatically make sure that the system is scaling up or down depending on how the current load is on the system. So 3 concepts, very quick recap. First is the range. Don't go beyond X, and make sure when you start scaling down, don't go below Y. The range is important. What condition you're going to target it on. Based on our experience with, we've been running this internally for a while, most of our typical internal customers keep the range between 60% and 80% CPU, because you don't want any spikes to cause scaling, because it just adds another instance and cost. So 60 to 80% is a pretty safe threshold to go monitor on. And then the next one to worry about is the step function of how you scale up or scale down. And the fourth and the last thing is the cooldown factor, on how much you want us to wait before we start shutting down and some of the instances to save money. So once you're comfortable with this, hit save. And what this does is the coolest part. It starts calculating not just the metrics, but how much money you'll end up saving between your peak capacity and your lowest capacity, based on your thresholds or your range, on how many CPUs you need. So, for example, I used to have a slide. I don't know, let's see if I still have it. is Skype is an internal service which runs on Azure, and Skype's peak load was several thousand cores. In the same day, the lowest capacity need were a few hundred cores. So typically, either somebody would come and manually increase or decrease, or they would just over-provision capacity. Now, with the help of auto-scaling, within a 30-minute window, they're able to follow the demand curve and the peak curve through the entire day. So that's the amount of savings. So for example, in this case, if you were Skype, it will not be 1 or 5, it will be thousands of cores, very different number to deal with. But then you'll actually start seeing, on an average of 60%, 40%, 50% savings in how much your CPU and core capacity gets used with the availability of the auto-scaling feature. So I know I went through a lot of concepts. Feel free to ask questions. Yes? So the question was, anything on the roadmap where instead of doing it on load or certain metrics, can I do it based on time? That's a great scenario where you can say, I know for sure every weekend I don't need so much capacity, so Friday evening, 8 p.m., start shutting down half the machines. Yes, this is very, very highly demanded, requested feature, definitely on the roadmap. Both one-time time shutdown, which is, hey, I want to take it down for maintenance, take it and then shut it down, or on a recurring basis, make sure every weekend or every last Friday of the month start shutting on, are both on the team's roadmap to go at. So, sorry, I couldn't barely hear you. Yes. Oh, thank you for bringing that up. So the question was, will this work on custom performance counters? Actually, I was trying to deploy the service right before we walked in. The service, this is still deploying, is actually using custom performance counters or custom metrics to trigger a auto scaling. So if you don't care about CPU or memory, you care about how many orders I'm processing or how many page views I'm getting, you can emit custom counters and use those instead of using the default counters or performance counters we gave out of the box. Of course, that does not work for virtual machines because you cannot write custom counters in virtual machines or VM hosting yet. It does work for cloud services, though. So, quick summary, or more importantly, a quick comparison between auto-scaling for websites versus cloud services versus virtual machines. Cloud services is the most complex and the most fine-grained control you can have because you have multiple tiers, multiple conditions. It's a scaled-out architecture. For websites, it's a lot easier. And all you have to do for websites is, come on. Let's configure. In this case, so by the way, this was my blog. Let me go back real quick and show you. So this is my blog, which is keeps going up and down. Active users, daytime, nighttime, it stops. On an average, I save about 75% on my builds just because I make sure that evenings it automatically starts shutting down the number of extra instances that I requested. So how I did that was I just configured a very straightforward set of rules. And for websites, it's pretty straightforward, which is it's based on CPU only. There's no notion of queue depth because it's only a single tier. You can both scale up as well as scale out. And that's something different between cloud servers and VMs. You can either say my application needs more power, but I just need one instance. And then you can go between instance sizes. So say, hey, instead of small, if you see load, add a medium or go to a large. And the good thing with websites is it's almost near instantaneous for it to go up between machine sizes. Unlike cloud services, where you do redeployment and other things. In this case, let's do a scale out. Pick the machine size. Again, high threshold, low threshold. And the target CPU. So of course, I've kept the CPU pretty low just to show you this demo. But typically, I would keep this at somewhere between 60 and 90% as well. So anytime my website starts seeing 60% CPU spikes, it will add one more instance automatically. And yeah, so my blog's rules are now in action. And next time, every time the CPU hits 60%, it will automatically scale. So the good thing with websites is you don't have to worry about a lot of the different roles or different step functions because scaling action happens within minutes, or actually usually it's mostly a few seconds. but up till a minute, you will be able to add a lot more website capacity. In case of cloud services or virtual machines, it takes several minutes to deploy a new instance. So think of that when you're thinking of your auto-scaling rules and thresholds. You have a question back there? No. No. So it's in the case of websites, we automatically defaulted to watching it for last 15-minute average. In case of cloud services, let me show this to you real quick. You can actually define the window of measurement yourself and say, I want to watch this for 5 minutes, 15 minutes, 30 minutes, and that was what the drop-down lets you do. So you have more control when you need, but for websites, the metrics are available only at a 15-minute granularity, and that's an average across all instances for that period of time. The last one is virtual machines real quick here. It's the same set of pointers, but for virtual machines, I'll come back to the question in a second. For virtual machines, the biggest difference is, it's not a scale-out architecture by definition, because you have one single instance. So to use, and you'll not find this feature automatically in the portal, for you to set up auto scaling, you have to have multi-instance VMs. What that means is you need to configure what's called an availability set. So for those of you who are using VMs and IaaS, you essentially set up the same VM, multiple instances, behind an availability set, a single endpoint, so that traffic can go to any VM. Hence, this can work only for certain workloads. So for example, if you have a SQL database or SQL server running on a VM, and the database is not replicated automatically, you cannot do this, so don't try doing it because it won't add any value. You don't want to spray traffic to a database which is completely different data than the other one. Unless you've figured out how to do replication yourself, it's a different story. But SQL is probably not the best workload to do auto scaling, but web is a classic awesome workload where you can actually just spray traffic, or load balancers, or Active Directory, any of those instances where the data is same. As long as the machines are behind an availability set, which means they are essentially scaled out architecture, you can configure auto scaling for virtual machines using the same principles as cloud services as well. Okay. Any other questions? It's okay to applaud if you like the feature as well, by the way. So the question was what kind of sampling intervals and what sampling data. The frequency of getting data, and actually I should switch real quick to a slide deck to explain how this actually works as well. So this is just a quick underlying architecture so that hopefully it answers a lot of those questions. What we're doing is we're querying the metrics. So the system goes and reads metrics from all services within Azure, whether it's availability, which is the outside-in monitoring I talked about, or for any of the compute, whatever metrics are available. In case of cloud services, you can get even custom metrics, because that's a place that's available. All those metrics at every 5-minute frequency end up in the rule store. That's where we evaluate the different rules you set for auto scaling or for sending emails and alerts. And every 30 seconds, a rule is kicked off, or all rules get processed. So assume anything between 1 minute to 5-minute latency between data collection and sampling window. Assume about, worst case, 30 seconds or so for the rules to get processed to see whether it makes the criteria, applies or not. And then for websites, the action is near instantaneous. And for VMs and cloud services, it usually takes a few minutes for it to spin up a new instance. So what that translates to essentially is, by the time you see load increasing and your service is automatically scaled up, you should factor in anything between a 15-minute to a 30-minute window before you'll have automatically capacity available. So that hopefully should answer the whole pipeline of collection, evaluation, and then corrective action being taken. Anything between 15 minutes to 30 minutes for VMs and cloud services. For websites, is anything between 5 minutes and 10 minutes. There's a question back. Yeah.
Is there any method of suppression of your notifications? Let's say you got one email and there's something wrong.
Great. Actually, it probably didn't show that correctly myself, but when an alert is active, let's just leave the alert, you only get, so for example, a condition gets hit that says my CPU is more than 60% over the last 15 minutes. If it stays at 60%, you will not get any more emails, even if it stays 60% for the rest of the day. Instead, what you'll see is that the alert is still active, and it was active for 10 minutes. Only if the alert gets resolved and gets reactivated will you get the second email. So by default, notifications are automatically suppressed till the time the condition gets corrected. And if you start seeing a lot of active resolved pattern, one or two things is going on. One, the system is thrashing, so you really need to look at the code on why it's spiking. Or you set the thresholds to be a very, very fine bar. Like, for example, when I had the 0.6 millisecond for my website, that's a pretty crazy number to set. That's only for demo purposes anyway, so that you can see the lines going up and down. But typically, we'll keep it at a more generous threshold, like 1 second, and 99% of your conditions should be under that. If you do still see a lot of thrashing of activated resolved, Outlook has this awesome feature called rules and alerts to filter out stuff, so it always works. So, you had one more question there. Yes, for websites, this is available only for reserved instances, which, as of this morning, are called standard instances. So we changed the naming. We'd love to do that because we need to keep our marketing guys busy. I hope no one's in the room for marketing. So it's available only for reserved or standard instances. It's not for the free tier. For cloud services, and the same thing will be true for mobile services as well. So auto-scaling is not available for mobile services today. It'll be added pretty soon. But same thing will apply. It's not available for the free tier. It'll be available for the standard or the paid high-level tiers. So we just quickly talked about this. I have about 30 minutes. I really want to leave more time for Q&A. But this pipeline is important to understand more from a perspective of how much capacity to pre-provision. If you go like super aggressive on scaling up, scaling down, or setting up alerts and thresholds, you might get either too much delay. So for example, you're doing custom perf counters. If you're collecting custom perf counters yourself, doing aggregation, the latency between alert getting kicked off or orders getting kicked off can be pretty high because you're doing calculations, we are doing calculations, and we're doing evaluation. So think about how and what you're collecting. If you're collecting base metrics, we take care of it automatically, and it's a guarantee between 1 minute and 5 minutes. If you're collecting your own metrics, something to think about from latency perspective. And also keep in mind that it takes anywhere between 5 to 15 minutes for the final rule to kick in, depending on your sampling and your watch window. So you should always have enough capacity provision to deal with the 15-minute spike. So you cannot just run on one instance and say, hey, as soon as my second user comes, I'll automatically scale up. It won't work. So make sure you don't go below a certain min-bar capacity as well. Otherwise, you'll definitely see performance degradation for your users if you're heavily expecting only auto scaling to go resolve that condition for you. For websites, you can be a little bit more aggressive because it scales up very quickly, scales down relatively quickly. But for anything which requires a few minutes to deploy, factor that thing in. One other thing, the slide talks about SMS. Today, the system supports sending out emails. Of course, you can sign up for third-party services available through Azure Store, like PagerDuty, which can send you pages as well if you need to. Or there are a whole bunch of other partners like SendGrid, which can have very, very fancy rules management. SendGrid is available for Azure customers at a pretty heavily discounted prices as well through Azure Store. So those are other services that we partnered with to have access to and you can use to customize and have very, very fancy alerts and rules management as well. So 1 quick minute on System Center for the 2 Supermicro Loyalist customers who actually have System Center. We did announce the availability of the Windows Azure management pack from System Center back in MMS. And it has a whole bunch of new features, including the ability to see topologies, watch for certificates and certificate expiry. Especially if you're doing automation, it's very, very important thing to worry about, which is your certification shouldn't expire before the service is brought down. The best thing about System Center tools is it's not just for monitoring, it's also for doing full deployment and application lifecycle. So System Center using virtual machine management, app controller, and System Center operations manager lets you manage the entire lifecycle of your virtual machines and cloud services through the SCOM console. So if you already use System Center, You don't have to get anything else. The management pack is free. Just download it, download the management certificate, and make it point to your Azure subscriptions. It'll start creating these fancy topology diagrams and alerts and rules for you, so you can actually go use that as well. I will skip over the System Center demo in the interest of time, but the management pack is available, and it lets you do all these services. System Center pack does not support services like mobile and websites today, but the team is definitely working hard to add support for more and more services there as well. So, I briefly talked about the availability of certain partner solutions. So I talked mostly around monitoring, DevOps, management today. I didn't talk a lot about deployment and provisioning. Especially when you start using virtual machines, services in Azure, and you need to have templatized deployments, for example, my SharePoint form or my Active Directory, we have a great partnership with RightScale. They actually offer both Linux and Windows-based VM provisioning in an automated way. They create templates, they deploy it. So that's a great partner. So you can use either System Center solution, or you can use RightScale, which is a service, so you don't have to deploy anything, which will help you with the provisioning, deployment, automation parts. The first two partners, the other partners are AppDynamics and New Relic. They do very, very rich monitoring within the application itself. So all those features we talked about, except for custom counters, we're looking at metrics like CPU, memory, outside-in monitoring. But if you want to do code-level debugging and analytics, solutions from AppDynamics and New Relic require an agent on the box or on your application. And if you want to hang around, or maybe at the Ask the Experts, I can show you a demo of New Relic as a partner announced the availability of supporting websites as well. So you can deploy the mini agent using as part of your website itself, and they can do pretty rich monitoring on different browsers that are accessing your site. Very, very rich analytics. So we have a bunch of great partnerships. All these solutions are available through Windows Azure Store. So you don't have to go reach out to any of these vendors to go buy it separately. It'll be part of your Azure bill and Azure subscription itself. So you can go through Microsoft, and we make sure the partners we add to the stores are very, very well curated to give you the same level of SLA and support that we expect from Azure platform itself. So a few partners are listed here. Try out the Windows Azure Store. You'll find a few more other interesting solutions, from sending email to PagerDuty to doing auto-scaling based on other business rules that we don't support. So it's a pretty vibrant ecosystem of solutions. So hopefully, either your existing third-party solutions are here. If not, I would love to hear which other solutions you use today and which ones you would like them to support managing Azure as a first-class citizen. So we have 7 minutes left. Essentially, the big takeaways are twofold. One is when you can kick the tires, start using, but when you actually are deploying production workloads, you need to go back to the whiteboard, think about your overall management strategy, what tools you'll use depending on what stack you're using, and then what automation you have in place, what authentication in place. So the slides will be available, but put some thought into setting up a management strategy upfront. So you're not dealing with fire drills of certificates getting expired or wrong people have access. We hear a lot of that because it starts organically, which is good. But it's time, as the platform matures, something for you to think about is the same processes that you used to do management on premises, they need to morph, and how to think about monitoring in the world of cloud services, which is different than how you do it on premises. And wherever possible, heavily automate. We believe in the principle ourselves. That's why auto-scaling, providing PowerShells and scripts is something that we offer as a first-class citizen in the platform. But the more you automate, the less time you have to worry about managing the apps and services in Azure. So